episode 5, and this is the ship it episode. So, episode 3, it trained the model, and episode 4, it turned it into a match replay engine, and episode 5 is where we do what most tutorials skip: validation, comparisons, and packaging. Because if you can't trust a probability, you haven't built a predictor, you have built a confidence generator. So, here's what's happening in episode 5. We already have a baseline logistic regression model from episode 3, and today we will do 3 big upgrades. So, first, you have your proper evaluation workflow. That means you have your train, validation, test split by match ID. And second, you have a stronger model variant. So that means you have logistic regression with L2 regularization and early stopping. And third is release packaging. So that is basically your comparison report, your overlay plots, and a final deployable model packed JSON. So this is the difference between a tutorial project and something you can actually ship. So, quick recap: Episode 3, it trained the baseline win probability. Episode 4, it replayed a match and explained turning points. And episode 5 is quality assurance and packaging. So, I'll just open up my code base over here and you can see these imports at the top. So, we are still using the same constraint: only pandas, numpy, matplotlib, JSON, and OS. No scikit-learn. So, every metric and training loop is something we understand. Now, as you go down, you have your data path and you have your baseline model path. So, what is that? So, these variables, they define the entire experiment. So, we read the match state balls.csv, then we load a baseline model from episode 3, then we write models, plots, and reports into outputs, and at last, we define the train, val, test split fractions, then logistic regression training settings, L2 regularization strength, and early stopping behavior, and the exact feature list that we use. So, a small thing that I want to add is hyperparameters are like masala: too much and it's chaos, too little and it's boring. So in episode 3, we did train, test, split by match ID, good. But production workflows use train, val, and test. So train, you learn weights. Validation, you decide when to stop training or tune hyperparameters. And test is basically final score you don't touch until the end. So this prevents accidental overfitting and makes the evaluation honest. Now I'll go down and I'll start explaining you guys all the functions that we have used. So as you know, we have our first function over here, that is ensure hyphen dir. So I already explained you what this function does. So this creates a folders even if they don't exist. So saving reports and plot, it basically never fails. As you go down, you have your sigmoid function. So sigmoid, it converts the logics into probabilities, and the safe clip avoids the log 0, which would literally break the log loss. Now without clipping, Python doesn't crash politely, it throws a tantrum. Now, as you go down, you also see a function that is standardized fit. And what exactly is that? So, this is the biggest real ML concept in episode 5. So, scaling. We compute mean and standard deviation using training only and then apply it to validation and test. Because if you compute scaling using full data, that's leakage. Now, if you go down, you see a train val test split by match. Now, what exactly is that? So this function, it splits by match ID. So we never leak rows from the same match into multiple sets. So you can think of it like each match is one independent unit. Now I will go down and I will scroll to my metrics section. So first, you have your log loss. So these are all the metrics. You have your log loss, you have your beer score, you have your accuracy, you have your AOC, ROC that we defined in the previous episode. So first, I'm gonna start with log loss. So what exactly is log loss? So log loss is the most important because we are predicting probabilities, and if the model is confidently wrong, log loss, it punishes heavily. So second, you have your Breer score. So Breer score is mean squared error of probability. So this is about calibration quality. And third, you have accuracy. Now accuracy is okay as a sanity check, but it can be misleading for probability models. And when you go down, you have your AUC and ROC. So AUC tells us the ranking power, like, do winning states generally get higher probabilities than losing states? So we compute the ROC curve manually and integrate using trapezoids. So I'll just add on a small thing. AOC is like how often the model vibes correctly because it can't really vibe mathematically. Now, with that, I'm just gonna go down. Now I have my load baseline model over here. So this loads the episode 3 baseline model JSON that we defined, which is your weights, bias, mean and standard deviation and feature order. So I'll just open the JSON file for you so you have a better idea. So this is a JSON file that we had. So basically we are feeding all of that into this episode. As we go down, you have your predict was saved. So what does that do? It's standardizing using that model's mean and standard deviation, and it predicts the probabilities. Now notice baseline and episode 5 model may use different scaling depending on how episode 3 was trained, but that's why we preserve each model's pre-processing inside its JSON. Now, as I go down again, you have your log training plus early stop. Now, first you have your fit log where basically this is the core upgrade in the episode 5. So we train the logistic regression using gradient descent, but with two production features. So you have your L2 regularization. So here we add 2 multiplied by lambda multiplied by w to the gradient. So this discourages the huge weights and reduces the overfitting. And second, you have your early stopping. So every epoch, we compute the validation log loss. So if it stops improving for patience checks, we stop training. So we don't waste time training forever and we don't overfit the training set. To give you a better idea in conclusion, early stopping is the model saying, boss, I'm done, and stop making me grind. Now we'll go down to our plot section. So we made a lot of plots in our previous episodes, and today we will be covering plot ROC overlay, calibration points, plot calibration overlay. So all of this would be covered. So these plots are what make episode 5 presentable. So you have your ROC overlay, which is basically the baseline versus the improved on the same chart. Then you have your calibration overlay, which are the probabilities honest, and then you have your coefficient compare. So basically it's like, does L2 shrink weights and make the model more stable? And this is where we catch the model lying nicely. Now you can see all these plots over here, and guys, you don't have to worry about the code. I will attach the link to my code base in the description, so you can just click on the link and you'll be here and you'll have the code to yourself. Now I'll go down and scroll to my main section over here. Now the main functions, it runs the whole pipeline in order. So it creates the output folders, it loads the mass_state_ball.csv, it filter innings to and drop NAN, then it split matches into train, val, test, then it standardized features using training only, then it loads the baseline model and evaluates it on the test set, then it trains the improved model with L2 plus early stopping. Then it also evaluates the improved model on the same test set. Then at last it saves the comparison report, it saves the improved model JSON, it saves the plots, and it saves the final release pack JSON. Now let's just run our code and see where this code actually brings us. So I'll just enter, like, I'll just open my terminal over here and I will run this command python. So I'm just going to run this command, that is python, and then your file name. So you have episode 5 validate compare package.py. And then you can see that you will see lines like epoch 50 val log loss, and you have epoch 100 val log loss. So this is a validation checkpoint logging. So if the validation log loss improves, the model is learning generalizable patterns, and if it stops improving, early stopping kicks in. So basically it's like when early stopping triggers, it's the model politely saying, I have done enough, please let me rest. Now I'm just going over to my output section and where I'm going to go over to my report. Now I'll just open this file, that is summary.txt. Now this report is the scoreboard for episode 5. We compare baseline versus the improve on the same test set. So you have your log loss probability quality, you have your Brewer calibration, you have your accuracy, that is basic sanity, and you also have your AOC, that is ranking power. So if improved model beats baseline on log loss and Brio, that's a real upgrade. Now I'll show you the ROC overlay plot. So I'm going over to my output section over here. Then I go over to my plot section and I'm going to open my ROC overlay, that is over here. And as you can see, this ROC overlay shows both curves. So if the improved curve is consistently above the baseline, it ranks winning states better. So think of it like baseline is pretty sure and improved is pretty sure but smarter. Now I'll also open the calibration overlay. So I'm just gonna scroll over here and I'll see my calibration overlay over here. Now this is the plot I personally trust the most. So if the model says 0.7, does it actually win around 70%? The closer we are to the diagonal, the more honest are the probabilities. So, because a model that's always confident is basically the one friend who's never wrong, but is actually wrong. Now, with that, I'm just going to scroll over and open up my coefficient compare.png. Now this plot shows what L2 regularization actually did. So typically L2 shrinks and coefficient magnitudes and prevents extreme reliance on one feature. So if weight they become more balanced, the model is usually more stable. Now I'll also open my logreg.json file, which is over to my model folder over here. And this is the JSON file that I have right now. So this is the improved model artifact. It includes the weight, the bias, the feature list, the mean standard deviation used in episode 5 training, the lambda value, and the best epoch and best validation loss. And yes, this is deployable. Now, I will also show you my final release pack.json. So that is over here. Now, this is the final deliverable. So it's like a mini model card. So basically where the model baseline lives, where the improved model lives, it also has the feature list, both metrics, training configuration, split ratios, and seed. So this is what you'd attach to a real release, and this is the model's passport. So it can travel now. Now I also just share a few questions that you guys mostly ask. So, why log loss matters more than accuracy? So, accuracy treats a 0.51 and a 0.99 prediction the same, but in win probability, we care about confidence. So, log loss punishes a confident wrong prediction way more than a slightly wrong one, and that's why log loss is the main KPI for probability models. And second, you have that why calibration matters in sports analytics. So, if your model outputs 0.82 often, but reality wins only 0.6, you can't trust it for decision making. And calibration is the difference between entertainment and real analytics. And third, you have what L2 regularization is doing intuitively. Now, L2 is basically a penalty for extreme beliefs. So it forces the model to distribute credit across multiple features instead of going all in on one. And with that, episode 5 completes the series. So you have your feature engineering, you have your baseline model, you have your inference engine, and you have your turning points and what if. And finally, in this episode, you have validation and final packaging. So if you want the next logical step, that is building a small UI or API around this model. But as a sports analytics project, this is already a full end-to-end pipeline. So thank you so much and stay tuned for the next series that we are about to launch.